Hey everybody, welcome to Cyber School, I guess. It's going to be pretty interesting to see how this actually works out. Uh, Here's our first lesson, right? The quadratic formula. Now, what were we doing before we left? We were solving quadratic equations, right? We had solved them by factoring, and we solved them by looking at a graph, right? If you recall really quick, when you look at a graph, the x-intercepts are the solutions, right? We sometimes call them zeros or roots. Either way, you might remember that if you were graphing and your x-intercept was not perfectly on a number, you really couldn't tell what it was, right? What was it, 2.75 or 2.83? I don't know. There's no way to know, right? Unless you use the quadratic formula, right? So the quadratic formula really is something that allows us to solve any quadratic equation. It has the potential to be the longest method, which is why we don't teach this first, right? If this solves any of them, why wouldn't I just use this all the time? Well, because it's lengthy, right? You don't want to spend all your time solving every single equation. If there's faster methods, which factoring is a faster method, graphing is a faster method as long as you have a calculator, they are faster. So we show you how to do those. But theoretically, if you wanted to, you could use the quadratic equation to solve any quadratic equation, right? This formula right here. Now, it looks complicated, but it really isn't, right? So you have x equals negative b plus minus b, the square root of b squared minus 4ac all over 2a, right? So in the square root, you have a b squared minus 4 times a times c. Right? In front of the square root, you have a plus minus sign. If you've never seen that before, that just means it's both plus and minus. So I can just show you real quick. Like, let's say I had 4 plus minus 7. What that would technically mean is to do both 4 plus 7 and 4 minus 7. So, 4 plus 7 is 11. 4 minus 7 would be negative 3. So that's just the meaning of this little plus minus here, right? Anyway, it does say that it solves any quadratic equation in standard form. That is important. It has to be written in standard form. Remember what that looks like, right? So, standard form is ax squared plus bx plus c. So, the capitals here, there's lowercase in the equation. Doesn't really matter. A, B, C, right? AX squared plus BX plus C. Those are the A's, B's, and C's that you see in this formula. Now, technically, given the fact that this is all online, you don't have to memorize this thing, but it would be in your best interest to do so, right? Negative B plus minus the square root of b squared minus 4ac over 2a. I mean, by the time you're done this section, you really are going to remember the equation whether you like it or not, because you're going to use it enough times. If I were you, I would write down the formula before you plug any numbers in. Because if you write this formula down for every problem that you do, the more you write it down, the more it'll stick in your head, right? So what I did is I have an example here, and this example is actually one that we could use factoring to solve. So I want to show that to you first, just so I can prove that this method also works, right? So x squared plus 4x plus 3. If I was going to use factoring to solve this, right, you break it down, and you try to figure out what's going to multiply to 3 and add to 4. Well, first, x squared comes from x times x, right? So what's going to multiply to 3 and add to 4? 3 and 1. So plus 3 plus 1, right? Why this is not right. So x plus 3 times x plus 1. Then you have to separate those factors, right? X plus 3 equals 0, or x plus 1 equals 0. And then you solve your equations. Subtract the 3, so x equals negative 3, or subtract the 1, so x equals negative 1. So if you solve by factoring, you get negative 3 and negative 1. Let's solve it using the quadratic formula and see if we get the same results. So first, let's identify our a's, b's, and c's. In this equation, a is 1, right? 1 in front of the x squared. B is 4, and C is 3. 1, 4, and 3. So what I will do is I will take those 3 numbers and plug them all into this formula here. So let's see what I get. So negative b, so that's going to be negative 4 plus or minus the square root. Okay, so what is it? B squared, so that would be 4 squared minus 4ac. So a is 1 and c is 3. All over 2a, in this case, a is 1. Now, with such a complicated looking formula, it is easy to get overwhelmed. So don't try to do too much at a time, right? Take it piece by piece. So if we look here, well, first, that negative 4, I can't really do anything to that. That's just going to stay negative 4. Plus or minus. Now, most of the work that I'm going to be doing is actually in the square root itself. So I have 4 squared. Well, isn't that 16? So I'm going to put a 16 here. Minus, now this is 4 times 1 times 3. So 4 times 1 is 4, and then 4 times 3 gives me 12. So it's really 16 minus 12. In the denominator, that's just 2 times 1, so I'll get 2. So all I really did was the 4 squared to get 16, and the 4 times 1 times 3 to get 12. Well, look at what's in the square root now. 16 minus 12. That's easy enough. So I'm going to put down here, what's 16 minus 12? Well, I'm pretty sure that's a 4. So I'm going to get negative 4 plus or minus the square root of 4 over 2. Okay, well, what's the square root of 4? It's 2, isn't it? So negative 4 plus or minus 2 over 2. Okay, so again, all I've really done is all the stuff under the square root, right? 4 squared is 16, 4 times 1 times 3 is 12. 16 minus 12 is 4. the square root of 4 is 2. Now, I really can't do anything else with what you're looking at, but I can split it up now. So remember what this means. That plus and minus means I have negative 4 plus 2 over 2, and I have negative 4 minus 2 over 2. Now I can do the rest of the math. Negative 4 plus 2 is negative 2 over 2, which equals negative 1. You might notice negative 1 was one of the answers I had over here. We could take a guess that the answer here should be negative 3. Let's see. Negative 4 minus 6, whoops, gave you the answer. Negative 4 minus 2 is negative 6 over 2. Negative 6 divided by 2 is negative 3. So at the end of the day, your solution is x equals negative 1 or x equals negative 3. So all I did was take the a, the b, and the c, plug it into the formula, and then I did the math. I mean, it doesn't really get any more simple than that. This is what we call plug and chug, right? Plug it in and chug away, right? You're just following the order of operations. Multiply first, then subtract, then you can do the square root. You kind of treat square root like parentheses, where you do everything under the square root first, then you can take the square root, and then, you split it up, do the plus, do the minus, get your two answers. We already knew it was supposed to be negative 3 and negative 1, and this is what we got. Let's try one where we don't already know what the answers should be. Okay, so just like last time, I would like to start by just identifying the A, the B, and the C. In this case, A is 1, B is 2, and C is 1. So I have to plug those numbers into my quadratic formula. So I'm going to start by actually writing the formula out. Negative B plus or minus square root of b squared minus 4ac all over 2a. The more you write the formula down, the more you will remember it. Now I'm going to plug in my numbers. So negative 2 plus or minus 2 squared minus 4 times 1 times 1, right? Because A and C are 1, all over 2 times 1. Okay. Let's simplify what's under the square root first. So negative 2 plus or minus the square root of 2 squared is 4, and 4 times 1 happens to be 4 as well. So I get 4 minus 4 under the square root. 2 times 1 is 2. All right. So the next thing I would have to do is 4 minus 4, right? Well, 4 minus 4 is actually very, very simple. I'll get negative 2 plus or minus the square root of 0 over 2. And the square root of 0 is just 0, right? So negative 2 plus or minus 0 over 2. Once you've gotten rid of the square root, you are ready to split it up. But something interesting is going to happen here. I'm going to get negative 2 plus 0 over 2 and negative 2 minus 0 over 2. They're both going to be the same answer. Negative 2 plus 0 is negative 2, and if I divide that by 2, I get negative 1. Negative 2 minus 0 is also negative 2 over 2, which gives me negative 1. So that means there's actually only one solution here. And that solution is negative 1. So sometimes you only get one answer, and that's okay, right? With a quadratic equation, you could have two answers or one answer. Or no answers. I don't have an example of one here, but the way you would determine if there's no answer at the moment is if I had something like 4 plus or minus the square root of negative 7 over 3. Why? Because I can't do the square root of a negative number, right? If you try to do the square root of negative 7, you're going to get an error because you can't actually take square roots of negatives. So this would be a situation where there's no solution or no real answer. We'll talk about what that means in a few lessons. Now you might notice that this one also turned out to be a pretty nice number, right? Before we got negative 3 and negative 1, now we have negative 1. Most problems that require the quadratic formula, though, the numbers or the answers are usually messy. They're usually decimals. They're usually irrational decimals. So let's work through this example and see what that might look like. So just like before, let's label. A is 2, B is negative 5, and C is negative 4. So let's start with my formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. This time you have to be a little bit more careful about how you do it because I have negative numbers, right? In my previous examples, they've all been positive. But when you have negative numbers, you have to be a little more careful. So b is negative 5. So what I'm going to do is I'm going to put negative 5. I'm going to put it in parentheses. So plus or minus the square root of negative 5 squared minus 4 times 2 times negative 4, right? A is 2, C is negative 4. All over 2a, in this case, a is 2. So, negative 5, isn't that a double negative, which would cancel the negative out to make it 5? And in here, negative 5 squared is 25, and negative 4 times 2, so that's negative 8. And then negative 8 times negative 4 would actually make it positive 32. That's what I meant when I said you have to be very careful about the way you're using these negative numbers. Treat that like it's a negative 4. And a negative times a negative would be positive. And, 2 times 2 is 4. So, I can do the addition of 25 and 32 to get 5 plus or minus the square root of, 57? All over 4. Now, 5 plus or minus the square root of 57. You might notice that the 57 is not a perfect square. So what I'm going to do is, I just realized what I did here. Don't need the x equals part. Just equals, right? So I'm going to rewrite it. So the square root of 57. I'm going to have to put that in my calculator. And that is, oops, an irrational number. Usually with these long decimals, I'm going to want 4 decimal places. So I'm going to do, or 3 decimal places, sorry. Let's do 550. Now really, it's 7.5498. The 8 bumps the 9 up, which bumps the 4 up, right? So anyway, it's 5 plus or minus 7.550 all over 4, right? Now I can split it up. 5 plus 7.550 over 4, and 5 minus 7.550 over 4. Again, going to have to use my calculator for this. And if I do it, I get 3.137. So one of my solutions is 3.137. And if I do the other one, 5 minus 7.550, divide that by 4, I get negative 0.638. This is definitely the hardest type of problem you'll see here because the numbers are just a little bit messier. But at the end of the day, you're doing the same thing, right? You start with the formula, you plug in the A, the B, and the C, and then you just do the math, right? Notice the last thing you do every time is the division. You do not divide until the very end. The first thing you'll be doing is all that stuff under the square root, trying to get that down to 7.550. Once you've done that, you split it up and solve. It's nothing but a formula. You plug it in. You're not doing anything else with it. And that's everything you're going to need to know. I mean, not much to know. It's a formula and you plug it in. You just got to do it, right? It is nice to see different examples, to see different ways it could work out. But otherwise, this is it. So that ends this lesson. The number of the day today is 17. Now, what does that mean? Well, every lesson is going to have a number of the day, right? And that number of the day is my way of making sure that you actually watch this lesson. So on Google Classroom, I'll ask the question, what was the number of the day? And you tell me 17. That's how you're going to get participation points. It's almost like I'm giving points away, right? Because all you got to do is watch it and then tell me what the number of the day is. So that's it. Have a good day. I'll see you later. Bye.